Today we are going to study about formal charge and how to find out the formal charge of an individual atom in a polyatomic ion. In order to study the formal charge, first of all let us know the formula how to calculate the formal charge of individual atoms. So what is the formula? Formula to calculate the formal charge equals to the number of valence electrons minus electrons in lone pair plus half the number of bonding electrons. So we are going to use this formula to calculate the formal charge of an individual atom. Let's take one example, CO3. It's a polyatomic ion with a charge of -2. Now we already by grade 11 we already know the Lewis structure of carbonate. So let's draw the Lewis structure of carbonate. So carbon in the center with single bond and oxygen at the top, then we have single bond oxygen, and then again a double bond and oxygen. So there are three oxygen, two with single bond and one with double bond. Now let's put the electrons: 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And the double bond will have 1, 2, 3, 4. So now this is the Lewis structure of carbonate. Now let us calculate the formal charge of each atom in the polyatomic ion carbonate. It has an overall charge of 2 negative. So carbon has an atomic number of 6 with an electronic configuration of 2 and 4. So let's use the formula to calculate the formal charge of carbon. So the number of valence electron in carbon is 4 minus electrons in lone pair. We don't have any lone pair over here, or bonded. We don't have any lone pair, so we can write 0 plus half the number of shared electrons or bonded electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons are shared. So 4 minus 4 equals to 0. So the formal charge of carbon in carbonate ion is 0. Let's move on to the oxygen. So we can mark the oxygen as 1, oxygen number 2, and oxygen number 3. Let's take oxygen number 1. So we can just write oxygen 1. Electronic configuration of oxygen, atomic number 8, so 2 and 6. So number of valence electron 6 minus electrons in lone pair 1, 2, 3, 4, 5, 6. So we see there are 6 electrons in lone pair plus half the number of bonded or bonding electrons or shared electrons, 2. So 6 minus 7 equals to -1. So oxygen number 1 has a formal charge of -1. We see that oxygen number 1 and oxygen number 2 are similar. Both have single bond and sharing pair of electrons. So we can also write down oxygen number 2. The formal charge is also -1 or -1. Let's take oxygen number 3 because it has a double bond over there. So it will have a different formal charge. So again, valency number of valence electron 6, negative minus, open a bracket, electrons in lone pair. How many electrons are there? There are 1, 2, 3, 4. 4 electrons over there, plus half the number of bonded electrons or shared electrons. How many electrons is it sharing? 1, 2, 3, 4. So 4 electrons. So 6 minus 6 equals to 0. So the formal charge of oxygen number 3 is 0. So overall, we see that the overall charge is -1 and -1, that is 2 minus. So the formal charge of carbonate, overall formal charge of carbonate is -2 or 2 minus. Carbon has a formal charge of 0. The first and the second oxygen has a formal charge of -1, and oxygen number 3 has a formal charge of 0. So the overall formal charge of carbonate ion is 2 minus. Let's take another example of nitrate, another polyatomic ion which is very common, that is nitrate. Nitrate has a overall charge of minus. Now again, let's draw the Lewis structure of nitrate ion. Nitrogen in the center, one oxygen at the top, another oxygen at the bottom, and then the third oxygen at the bottom with a double bond. Now we can draw the electrons. First oxygen at the top, 1, 2, 3, 4, 5, 6 electron in single bond. Another one, 1, 2, 3, 4, 5, 6 electrons in single bond, completing its octet. And the last oxygen, double bond, then 1, 2, 3, 4, 4 electrons over there. And then overall it has a negative charge. Let's calculate the formal charge of each atom over there. Let's take nitrogen first. The electronic configuration of nitrogen is 2 and 5, and electronic configuration of oxygen again is 2 and 6. So let's take nitrogen first. Number of valence electron 5, negative, open a bracket. Electrons in lone pair, how many lone pairs are there? No lone pairs, so 0, plus half the number of bonded pairs or shared pairs. How many shared pairs are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 shared pairs. So 5 minus 4 equals to plus 1. So nitrogen has a formal charge of +1, plus 1. Now let's move on to the oxygen. So let's again put oxygen, number them because we have 3 oxygen, number 1, number 2, and number 3. So number 1 and 2 is single bond. So let's take number 1. So number of valence electron 6 minus, let's open a bracket, electrons in lone pair 1, 2, 3, 4, 5, 6. 6 electrons plus half. Then the number of bonded electrons or shared electrons 2. Close the bracket. 6 minus 7 equals to -1. So the first oxygen is -1. The formal charge of first oxygen is -1. We see that the first oxygen and the second oxygen are again similar with single bond and three pair of electrons, lone pair of electrons. So we can say oxygen number 2 is also having a formal charge of -1. Let's take oxygen number 3, which is different, having a double bond over there. Again over here, number of valence electrons, 6 negative, open a bracket. Electrons in lone pair, there are 4 electrons this time, plus half the number of shared electrons. How many electrons are there? 4. So 4 over there. So 6 minus 6 equals to 0. So here we see nitrogen having a formal charge of plus 1 and the other two oxygen having a formal charge of -1 and -1. So -1 is -2 plus 1. So overall -1. So the overall charge of nitrogen is -1. Formal charge of nitrogen is +1. Of oxygen with single bond is -1, and oxygen with double bond is 0. I hope you have understood how to calculate the formal charges.